Consider a column in which our neutral axis is beyond the column, that is, this is XU. The dimensions of the column are D and width is B. This is a CG point of the column. From CG, let us consider a section at a distance of Y bar. Stress at that section, let us say in concrete, is Fc and strain is epsilon. We need to determine the expression for Fc depending upon the strain epsilon. For that, let us consider the distance from the rectangular portion of the stress block, that is, this distance will determine. We know in the stress block the rectangular portion is still 7 by 3 of D and the parabolic portion is still 4 by 7th of D. Then when this distance is Y bar, this small distance will be D by 2 minus 3/7 of D, that is D by 14. And the remaining distance is Y bar. So from here, from the rectangular portion to our section consider, the distance will be Y bar plus D by 14. Let us consider separately the parabolic variation, in which this is a parabolic variation in which, let us say, at x distance y is the ordinate, then equation of this curve is y equal to mx square. Substituting boundary conditions, at x equal to distance is, when this is 3/7 of d, then the remaining distance will be xu minus 3/7 of d. Then y value will be, this ordinate is 0.446 fck. So here also the same ordinate will be there. So this value is 0.446 fck. Substituting, y is 0.446 fck, which is equal to m into x is xu minus 3/7 of d whole square. Then m will be equal to 0.446 fck into by xu minus 3/7 of d whole square. So our expression for y will be y equal to 0.446 fck into x square by xu minus 3/7 of d whole square. Then at x distance, that is x is now y bar plus d by 14, then say this is our y, then fc will be total 0.446 fck minus y. So writing that equation, when x equal to y bar plus d by 14, then our fc value will be equal to 0.446 fck minus y at a distance y at x equal to y bar plus d by 14, that is 0.446 fck into x is y bar plus d by 14 whole square by xu minus 3/7 of d whole square. On simplifying, fc will be equal to 0.446 fck will be common into 1 minus y bar plus d by 14 whole square by xu minus 3/7 of d whole square. Let us take the distance from highly compressed edge. Highly compressed edge. Then that distance y bar plus d by 2 is from highly compressed edge. Let us say it is some p, then substituting, in place of y bar we'll put p minus d by 2. Then fc will be equal to 0.446 fck into 1 minus y bar is p minus d by 2 plus d by 14 whole square by xu minus 3/7 of d whole square. This can be further simplified as fc equal to 0.446 fck, taking xu minus 3/7 of d as LCM. This is xu minus 3/7 of d whole square minus this value is p minus 3/7 of d whole square by xu minus 3/7 of d whole square. This can further be simplified as in the numerator it is a square minus b square formula, that is a plus b into a minus b. So 0.446 FCK into a plus b value is xu minus 3/7 of d plus p minus 3/7 of d into a minus b value is xu minus 3/7 of d minus p plus 3/7 of d by denominator is xu minus 3/7 of d whole square. Minus 3 by 7d and plus 3 by 7d gets cancelled. Then fc will be equal to 0.446 fck into xu minus p remains by xu minus 3/7 of d into the remaining value is xu plus p minus 6 by 7d by xu minus 3/7 of d. In the strain diagram, let us say epsilon is the strain at the level of our section. Consider this will be epsilon minimum, this is epsilon maximum, and at the fulcrum the strain will be 0.002. This distance is xu minus 3/7 of d, this is 3/7 of d. Till here our distance will be from the highly compressed edge, its distance is p, then this will be xu minus p. So from similar triangles, let us write the expression here only. Xu minus p by epsilon will be equal to xu minus 3/7 of d by 0.002. From this, epsilon will be equal to epsilon by 0.002 will be equal to xu minus p by xu minus 3/7 of d. Substituting this expression here, xu minus p by xu minus 3/7 of d will be, this is 0.446 FCK into, this will be epsilon by 0.002 into, let us put this same xu plus p minus 6 by 7d by xu minus 3/7 of d. Now xu, let us take it as p plus x1. Then from this xu minus p will be equal to some x1. Let us substitute back here. Fc will be equal to 0.006 FCK into epsilon by 0.002 into xu minus p is x1. Then xu will be p plus, substitute in place of p, from this p will be equal to xu minus x1, then xu plus xu minus x1 minus 6/7 of d by, this value is xu only minus 3/7 of d. This will be fc will be equal to 0.006 fck into, let us write it again, rewrite it as, from our expression obtained, epsilon by 0.002 will be equal to xu minus p by xu minus 3/7 of d. From this, substitute xu minus 3/7 of d value here, that will be equal to xu minus p into 0.002 by epsilon, where p is xu minus x1, then substituting xu minus xu plus x1 into 0.002 by epsilon, then xu gets cancelled, it becomes x1 into 0.002 by epsilon. Substitute it here, epsilon by 0.002 into this is 2xu minus x1 minus 6/7 of d by xu minus 3/7 of d value is x1 into 0.002 by epsilon, then Fc will be equal to 0.446 FCK into epsilon by 0.002 whole square into in the numerator it is 2xu minus x1 minus 6/7 of d by in the denominator it is x1, then Fc will be equal to 0.446 FCK into epsilon by 0.002 whole square into 1 by x1 into 2 into x1. Xu can be written as, we know, epsilon by 0.002 is equal to xu minus p by xu minus 3/7 of d, that is this value is x1 again, then xu minus 3/7 of d will be equal to 0.002 by epsilon into x1, and this is 2 times of 0.002 by epsilon into x1. On taking 2 as common in the numerator, it can be written as xu minus 3/7 of d minus x1. So this value we substituted back again in terms of x1 minus x1, that is equal to 0.446 FCK into epsilon by 0.002 whole square into 1 by x1. In the numerator x1 can be taken as common, x1 gets cancelled, then this will be 2 times of 0.002 by epsilon minus 1. On multiplying 0.446 FCK, this will become epsilon by 0.002 into 2 minus epsilon by 0.002 whole square. So this is the expression for Fc in terms of the strain at that level, that is epsilon, where our epsilon will be equal to 0.002 into xu minus p by xu minus 3/7 of d, where our p value we substituted is xu minus x1, where x1 we substituted is d by 2 plus y bar, so this becomes minus y bar. So our epsilon value will now be 0.002 into xu minus d by 2 x plus d by 2 plus y bar minus xu by xu minus 3/7 of d. Sorry, xu minus p value itself is in the epsilon value, xu minus p value is x1, so our epsilon is 0.002 x1 by xu minus 3/7 of d, where our x1 is xu minus d by 2 minus y bar by xu minus 3/7 of d is our expression for epsilon.